Hello everyone, welcome to this video. In this video, we'll be starting with normal subgroups. So we already know for any given group G, right? We can define a subgroup, let's call that by H, and for that particular subgroup, we may have many cosets. If we take some element A from this group G, right, corresponding to this A and this subgroup H, we may define either the left coset or the right coset, right? How do you define a left coset? It would be the element A taken from the group and together with H, right? And the right coset would be HA. So in certain cases, so now if once you remember these things about coset, subgroups, groups, so next question that comes to our mind is, do all the cosets they are different from each other? Actually, you do know the answer to this question. The answer is no. Why? Because we know that cosets of any subgroup, they partition the group into equivalent classes, right? We have some equivalence relation under which the cosets of any subgroup, they partition the group, right? Once they partition the group, whatever is our group G, we would have a fixed number of partitions here, and each would be disjoint to each other. And even if we have two cosets which are having overlapping elements, then those two cosets would exactly be identical, right? Either they are disjoint or they are identical in nature, right? However, in certain situations, we do not have this thing. It is not always true that AH is equal to HA for all the elements A in G. This is not always true, that the left coset and the right cosets, they are equal. However, in some cases it is. So we have a mathematician named Galva. You have heard about him, right? So this mathematician Galva, about 180 years back, he recognized those subgroups for which the left as well as the right cosets, they coincide with each other. So in particular, we are taking those subgroups for which both of them, they are equal to each other. So those subgroups, we actually have a special name for such kind of subgroups, which we call as normal subgroups, right? So they are saying the subgroups which have both the left as well as right coset equal for some given element from the group, we call them as normal subgroups. So how do we exactly define a normal subgroup? So let's see the definition. A subgroup H of a group G, that is called a normal subgroup of G if the left coset AH is equal to the right coset HA for all the elements A in G. So this thing is true for each member of the given group, right? If we take one by one the members of the group G and we construct the left and the right cosets and see whether they are equal or not, and this is done for every member. If that is there for each member A in G, we call that particular subgroup as a normal subgroup, right? As for an example, let's consider a subgroup of an abelian group. Suppose a group G that is abelian in nature. What is an abelian group? An abelian group is a group which is commutative in nature, right? So all the elements suppose we take two elements A and B, so they would commute. So all the elements here would commute with each other. So in this case, we would say, if we take this abelian group, whatever is the subgroup of this one, that would act as a normal subgroup. Now this is a very big thing to say, because we are saying every subgroup here is normal. Why? Because we know the property of abelian group, AB is equal to BA, for each A and B taken from the group G, right? This thing is there. If this thing is there, that means if you take any element A from G and then construct a coset AH and construct a coset HA, then they would be equal. Why? Because in this case, we always have, suppose we take some element H from the subgroup capital H, because H is a subgroup of G. So this small h would also be present in G. Now A is present in G and H is present in G and G is abelian, hence AH would be equal to HA in this case for all the A's, right? So therefore for all the A's present in the group G, we have the left coset equal to the right coset, and hence all the subgroups here, they are normal subgroups, right? So I hope you understood this normal subgroups. Now next let's have a look here. We denote H, this triangle sign G. This symbol here represents H is a normal subgroup of G. Remember, we use this symbol to represent that H is a subgroup of G. So we, instead of using this symbol, now we use this triangle symbol, we say H is a normal subgroup of G, right? This is the notation. Next, the next question here that I have mentioned is, how can we correctly represent the equality of two right cosets? Now let's understand this thing in more detail. Suppose we have some group G with us and the H as its subgroup, correct? And we take some element small a from the group G, right? Then in that case, if we consider this subgroup to be the normal subgroup, then according to the definition, its left coset would be equal to its right coset, right? So if we take this thing, so that means this thing would be true if we have some element here, let's call that as small h, and if we have some element here, let's call that by h dash, right? Such that this definition would be true. So a small h would be equal to h dash into a, right? Where both h and h dash, they might be different. However, they can be same, as in the case we have studied here in case of abelian group. However, in certain cases they might be difficult. So whenever we are looking for a normal subgroup, we do not have to look for this thing. Instead, we have to look for such a thing where this and this could be different, right? In a similar manner, if we take the right coset equal to the left coset, in that case we would say for some element h in capital H and some element h double dash in capital H, right? We are taking h here and h double dash here, so that h a is equal to a h double dash. In this case, this h and this h double dash, they also might be different to each other. Hence, we would say that it is possible in certain cases that h is equal to h dash or h is equal to h double dash, but this is in general not true for all the cases. Hence, we assume that in general, until and unless specified, we consider both the elements to be different, right? So this is the terminology, and that is how we use this notation for normal subgroups. I hope you understood this concept. Well, that is it for this video. Thank you for watching.